Hello again everyone, welcome back to ptet.chemistry channel. So in this new topic, a new series of lecture tutorials, I'll go through this new topic as I mentioned on structure and bonding. So despite the classification under atomic structure is actually a continuation of that, which was the last topic we did prior to this. In this particular lecture tutorial, I'll go through this concept on ion and ionic bond, where these apply to the 14 to 16 years old candidates sitting for this pure chemistry, single science, single chemistry curriculum. So candidates should be able to describe the formation of positive ions. So the fact that you have described, you got to talk about how you get positive ions known as cations. Well, we know that cations are positive ions. They come from metals. So metals lose electron. This was part of atomic structure we did in the last topic. And I will advise you to actually go back to why or how metals lose electrons and what kind of charge they will get when they lose however many electrons based on their position in the periodic table. Negative ions are known as anions, and of course we get it from the nonmetals. The nonmetals on the far right of the periodic table, they will gain electrons in order to get to a fully filled outer shell. And when they gain electron, you started from the atoms which are uncharged. When they gain electron, they become negatively charged species. All right. The next bit is also descriptions. So describe means not just a single word, but using sentences, get straight to the point. This is about giant lattice structure. This is the first time you have heard this, and it is a technical phrase that you have to use. So I didn't say a term because it is a collection of a couple of words. So it's a technical phrasing that you need to be able to get correct. So all ionic compounds have a giant ionic lattice. So they say giant lattice structure of ionic compound. That is actually called giant ionic lattice. So whenever you are asked about structure and bonding, you gotta state the structure, giant ionic lattice structure. If you have an ionic compound, and what is it? Well, it consists of a regular arrangement. So the fact that you are regular, think about your solid particles. They are tightly packed regularly in an ordered manner. Okay, so that was from your state of matter kinetic particle theory topic. So here you have regular arrangement of alternating positive and negative ions. Essentially what you have is positive, negative, positive, negative, positive, negative, and so on and so forth. So positive ion attract negative ions. So you're not going to put the positive ions next to the positive ions. The negative charge are in between them. So this is what it meant by alternating. So it alternates. It switches from positive, negative, positive, negative. Each of these are ions, respective ion. Cations come from the metals having lost electrons. Anions come from the non-metals having gained electrons. Now you have two different type of species. You have two different type of atoms. Sorry, two different types of elements. All right. So this is a compound because a compound consists or contains two or more elements. Okay, bonded together chemically in a fixed ratio. So these are not mixture. There's a certain fixed ratio because you got to balance out the charges as you have a compound, and compound overall is uncharged. So that's something we will deal with when we come across how to get the formula of ionic compounds later on. Now the very last thing we'll do in this lecture tutorial, we got to be able to state. Stating them is basically a definition. When someone asks you what is ionic bond, well, every single type of chemical bond is a force of attraction. Electrostatic refer to positive attracts negative. So negative attract positive, positive attracts negative. In the case of ionic compound, your giant ionic lattice consists of these alternating positive and negative ions. And these are your particles. So these are oppositely charged particles, and therefore they are attracted towards each other, and this is the ionic bond. You can't count ionic bond because it's a force of attraction. It's electrostatic force of attraction between these oppositely charged ions in this giant ionic lattice structure. So the structure of an ionic compound is giant ionic lattice structure. The bonding of an ionic compound is ionic bond. Do not confuse within structure and bonding. They are separate. You got to specify what is the structure and what is the bonding separately. Okay? Let's get started with the underlying concept, kind of repeat what I've just said, and these are basically very important to rejolt your memory, rejolt your memory again, for atomic structure from what I have just explained a few minutes ago on how you form ions. When we learn atomic structure, we know atom overall is uncharged, therefore we have equal number of protons and electrons. Ion on the other hand is charged particle. That's because we have unequal number of protons and electrons. Proton number is the identity of the element. So the proton number gives you the identity of the element. It's also known as atomic number. So atomic or proton number is the identity. You don't change anything inside the nucleus. Instead, what happens when you form ion is by losing or gaining electron. So how does an atom become stable? Well, it can become more stable when it has a completely filled valence shell or completely filled outermost shell. That means it becomes a noble gas electronic configuration. The way to do it is basically to gain or to lose electrons, especially when they have a metal and a non-metal partner. So basically these 2 points here can be a fill-in-the-blank kind of question. So the metals on the left-hand side of the periodic table, we consider the group 1, the group 2, and even the group 3 is on the other side, the right-hand side. Group 3 includes things like aluminium. Aluminium has a chemical symbol of Al, and it is considered a metal in a group 3 there. So group 1, 2, and 3 consider metals. They lose electrons. These are one of the most confusing concepts for a lot of students. We talked about these when we did atomic structure. You started out from atom, which is uncharged, and you have electrons, which have a -1 relative charge from your year 9 atomic structure topic. When you lose negative charge, you become positive ions because you have more protons than electrons. So positive ions are also known as cations. Cations come from metals having lost your outer shell electrons. However many outer shell electrons you lose depend on your group number. Are you group 1? Then you lose 1 outer shell electrons. Are you group 2? Then you lose 2 outer shell electrons. Are you group 3? Then you lose 3 outer shell electrons. Why? Because you want to go to completely filled outer shell to get to a noble gas electronic configuration. Okay. On the other hand, the non-metals on the right-hand side of the periodic table, things like group 4, 5, 6, and 7. I don't include group 8 because group 8 of the noble gases, they already have a fully filled outer shell. They don't bother to lose or to gain electrons, even though they are part of non-metals. They don't want to gain electrons because the group 8, the valence electron shell is already completely filled. There is the noble gas electronic configuration as stated in the atomic structure under electronic configuration. So these non-metals, they will gain electrons. If you are group 7, so VIR refer to group 7 Roman numeral, and they will gain 1 electrons and they will have a -1 charge ion. Group 6 needs to gain 2 electrons to go to a fully filled 8 valence electron. It has a -2 charge. Group 5 needs to gain 3 outer shell electrons in order to go to a fully filled outer shell, and therefore group 5 non-metal will gain 3 electrons and have a -3 charge. Minus charge, negative ions, because you have more electrons than protons. Since you gain electrons, you gain negative charge, you become negative ions. The name of negative ions is obviously called anions. That was what we had just discussed previously as part of the learning objective. Now, what is an ionic bond? We know it's a force of attraction between the oppositely charged ions. When do we get ionic bond? When do we get ionic bond? You gotta be prepared for this, all right? So the metal come from the group 1, 2, and 3. The non-metals come from the group 4, 5, 6, and 7. So these Roman numerals are how we represent a group number. They are as stated in your periodic table, which are given in an exam. The compound is called ionic compound, but the structure is going to be giant ionic lattice structure. Your bonding is going to be called ionic bond, formed between a metal and a non-metal. What actually happened? Remember what happened? Describe the formation of the ionic bond. Well, the metal itself will lose electrons. That electrons get transferred from the metal atom to the non-metal atom, and therefore the non-metal atom gain electrons, and you get anions, basically negative ions. And the metal having lost electrons, what you're going to get is you're going to get cations, which are positive ions there. Okay, and then you have oppositely charged ions. They will give you the giant ionic lattice structure, and the force of attraction between the oppositely charged ions give you ionic compound, ionic bonding. All right, so this is just the definition. students or candidates should be able to state the name of the bond where when you have a species which contain a metallic atom come from the group 1, 2 and 3, and you lose electrons to give you cations. The non-metals group 4, 5, 6 and 7 should really properly write that group 7 VII. They gain electrons and you get transfer of electrons from the metal atom to the non-metal atom. What is important is both of them do that. The metal atom lose electrons to get to a fully filled outer shell. The non-metal atoms gain electrons to get to a fully filled outer shell. Both the cation and the anion, resulting cation and anion, they have a fully filled outer shell because they obtained the noble gas fully filled outer shell electronic configuration. This giant ionic lattice structure is defined as regular arrangement of these alternating positive and negative ions. This is just a section of how the giant ionic lattice structure looks like for sodium chloride. This is now called a chloride ion. This is not chlorine atom. This is not chlorine molecule because it is now an ion. It has a charge. So be careful when you write the species Cl minus, Na plus. They would stuff you have learned from atomic structure. Now the ratio of these ions in the way they are arranged is 1:1. That's why the formula is NaCl. It means there's one Na and one Cl. But then this is between the non-metal chlorine and the group 1 metal sodium. So we know that this is an ionic compound with an ionic bond, and we get transfer of electrons from the sodium to the chlorine. Should be able to draw a dot and cross to represent that. If I draw dot and cross, so sodium is in the third period, so it's got 2, 8 in the second shell, and it's got 1 in the third shell. And then what happened is it will lose its 1 outer shell electrons, and it will lose it to 1 chlorine. If I just copy that and hang on, just give me a minute. Copy that and I'll paste that. What I want to show is I want to make this into chlorine, and I should be able to, that's not a good idea actually. Let me see if I can do this better. I should really do something else. We're going to represent ionic compound with dot and cross, so 2 electrons for the chlorine electronic configuration in the first shell, 8 in the second shell, and then I have another 7 in the third shell. So these are all straight from the previous topic coming under atomic structure. But what is important now is we are showing the formation of ionic bond. Therefore, we have to use different representation of the electrons in one species and the other. So we call this dot and cross. You could have gotten them the other way around. If you use dot here, then you use cross here. Perfectly fine. But what you must be aware of is which one is your original sodium, which one is your original chlorine electrons, and therefore we have to distinguish, tell apart the difference. All right. So we can see that there is a 281, there is a 287, because it's in group 7, it's in the third shell. This is group 1 metal. So what happened is this one will lose to that, and this one will gain the 1 extra electrons. So eventually you're going to get Na plus. I'm not going to show it now, but that is 28 because you have already lost 1 electron. This is now Na plus 1. You have already lost 1 electron. Therefore, you're only left with 10 electrons. You're only left with 2 shells that are completely filled. What happened with Cl minus? You're going to gain 1 electron, so it's 288 now. Because it's Cl minus 288, I can, if I want to, in fact, I better show it. If I just copy that, that is going to be how my sodium looks like. And I'm lose the outer shell. And do not forget, when I lose my outer shell, I am no longer an atom. I am now an ion. If I am ion, I need to show the charges very, very clearly, because you cannot leave any doubt in people's mind, because people see what they want to see, and you don't want to be mistaken. So I already gained 1 cross. I already gained the electron from the sodium. So what happened there is I am going to be a minus charge like that. So basically that is what happens. Describe the formation of ionic compound sodium chloride. The sodium has got one outer shell electron, loses the one outer shell electrons, give it away, and get a fully filled outer shell sodium ion, Na+. The chlorine is a group 7 element. It just needs one more electrons, and it receives that one electron that sodium atom loses to get to completely fill out the shell, and that's why I use the other electrons. I don't show all the dots because the dot originally was 7 dot, and now I use a cross to represent I have taken one electron from the sodium atom, and now I have a fully filled out the shell as well, but I have an anion. When I have cation and anion, metal and non-metal, cations from the metal, anion from the non-metal, I get ionic compound. The force of attraction between oppositely charged ions, that's called ionic bond, and my structure is going to be giant ionic lattice structure. Basically, what I've shown there was a dot and cross diagram. We don't show this kind of giant ionic lattice structure, but this is how it actually exists as in reality. And this ionic bond can also be formed between a simple ion and a polyatomic ion. So poly mean many, atomic mean, well, atom. And when you have many atoms forming ion, you have a charged particle. So we have things like nitrate here, ammonium nitrate. So you can see NH4 plus is cation. And then you have NO3 minus, which is anion. So when you have positive charge and negative charge together, positive ion, negative ion, you get ionic bond between them. Here you have Mg2 plus, here you have SO42 minus. This is magnesium ion from group 2 metal. They lose 2 outer shell electron. This is sulfate. These are polyatomic ion. The charges are not easily found, but there will be a series of ions that you need to remember, and I'll mention that in the upcoming tutorial video. But take it just as it is first. Sulfate, negative ion there, anion, cation, you get ionic bond as well. So you get giant ionic lattice structure, you get ionic compound, you get ionic bond formed between the cation and the anion. Alright, I'll just leave it there for this lecture tutorial, and I'll continue more on ions and ionic bonds in the next lecture tutorial. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. I'll see you in the next lecture tutorial.